Okay, so hello everyone. I'm Ting-Ju Chen. I'm a PhD student in the Department of Mechanical Engineering at Texas A&M University. And today I'm going to present QCue, Queries and Queues for Computer-Facilitated Mind Mapping. This work was collaborated with one of my lab mates, Ganesh, and our advisor, Dr. Krishnamurthy. So first, we want to talk about the mind mapping technique and the usage of textual stimulation in design. Mind maps are usually used for brainstorming and idea generation. It helps understand the relationships between different aspects of a central problem through a tree-like network of nodes. By tree-like, we mean that it is an acyclic graph. So this process of structuring information makes mind mapping an excellent tool to investigate a central problem in depth. The process of mind mapping sounds really straightforward. However, it may still hard for several people, especially novice users, for a number of reasons. First of all, the unstructured and ill-defined task may prohibit people from generating proper ideas. Second, the user might do not have enough knowledge in that specific domain. Or even if you have knowledge, you might find it hard to recall all of them. And then finally, while trying to organize, you may find it difficult to construct relationships between different aspects of the ideas. Therefore, in this work, our goal is to develop a cognitive support mechanism to address these issues while also allowing users to think more, think critically, and think creatively. The main idea that forms the basis of QCue comes from Gabriela Goldschmidt's work. Her work revealed that textual stimulations can improve creative outcomes in the design conceptualization process. Another example is the study by Quayle, explores reflection in design, and similarly, the Socratic method, which emphasizes the use of questions in enhancing critical thinking skills. So inspired by this, in our work, we want to explore how to use textual stimulation to improve the mind mapping process. In QCue, we use ConceptNet as the knowledge base to provide textual stimulation to the users. ConceptNet has a rich relational ontology and is good for making connections between different aspects of the concept. It is a semantic network with nodes representing real-world phrases and edges representing semantic relationships. The main advantage of ConceptNet is that the links between the nodes are explicit relationship types that can help people in understanding and making contextual inferences. Methodology. So with the idea in mind, in QCue, we developed our methodology based on the question query strategy and the topological and temporal evolution of the mind map. So our idea behind QCue's cognitive support is to stimulate users to think in new directions, but also do not intrude in their own line of thinking. To do this, we designed a question query mechanism. The idea is to use questions to help users to explore different aspects of a problem, and also use suggestions to help them with fine-grained exploration for each aspect. For this, we designed 3 different interaction modes for users to add new ideas to their mind maps: direct user input, input based on suggestions, and input based on response to the questions. In the first mode, direct user input, the user simply double-clicks on the existing nodes, input an idea or a concept in the dialog box as the content of a new child node in the mind map. The second mode, input based on suggestions, the user can query for suggestions in relation to a given node in the mind map, look for the provided suggestions, find the ones that they feel more comfortable with, and then add it to the mind map. Here, we use ConceptNet to provide those suggestions directly. And the third one is response to question node. Here, our algorithm provides automatic questions to the users. By simply responding to the question, results in the addition of a new child node to the mind map. In QCue, for providing suggestions, we look into ConceptNet retrieve the linked concept, and then we show it to the user for giving them a diverse variety of ideas to consider. Here, the suggestions help the user maintain the rate of idea generation. Our idea for question generation is to stimulate the users to think about different aspects of the node's content. For this, we found that the relationship types in ConceptNet are excellent for generating such questions. For example, given a content of an existing node garage and the relationship types from ConceptNet, we can generate something like this. What is garage used for? And add it to the mind map. Here, questions can not only help the user think about different aspects of a concept, but also look for appropriate suggestions. We consider the temporal and topological evolution of a mind map to decide where to generate the questions. Suppose this is how a map evolves over time. So our idea is to generate questions at nodes that have either missed the user's attention for a long time, that is the temporal aspect, or that have been less explored in comparison to other ideas at similar hierarchy in the mind map, that is the topological aspect. So for this, we implemented a method that uses two types of penalties to find the target node. The first one is the time penalty. Here, time penalty of each node was set to 1 upon addition. With the time elapsed, we reduce the penalty value by a constant c. And if the node becomes active during mind mapping, we then set back the value to 1. For example, given any state of a mind map, we assign the time penalty of each node like this. This penalty can help users explore nodes that have not been visited for a long time. Second is the lineage penalty. Here, we first compute the total number of child nodes with respect to each node, and then we normalize it across all the existing nodes, and then we subtract the normalized numbers by 1. So the idea for this penalty is to find targets based on their relative depth in the current mind map. We make this penalty of leaf nodes to be 1 such that it implies more refined and depth-first exploration. So given any state of a mind map, we assign the 2 penalties to each node like this. With the assigned penalties for each node, we provide 2 sliders on the QCue interface. These sliders allow the users to adjust threshold values for determining where to generate questions. One corresponds to the time penalty, and another one corresponds to the lineage penalty. So if the user increases the time penalty threshold, then the questions is going to be generated on nodes that just become active. The reason is that those nodes have the highest time penalty. So for example, in this existing mind map in the left-hand side, you can see these 2 nodes are going to be selected based on this. And then on the other hand, if the user increases the threshold value for the lineage penalty, then leaf nodes are most likely to be selected to generate the questions, since the lineage for them is the largest. For example, in this mind map, you can see these 3 nodes are going to be selected based on this. We now notice that there is one node in this mind map, the repair, meets both the condition, the threshold for lineage and time penalties. So this node therefore becomes a candidate for QCue to generate a new question node on. Once a target node is determined, we use ConceptNet relationship types and generate a question based on the relationship with the highest possible weight. Now, note that throughout the paper, we use the weights data directly provided by ConceptNet. After the development of the algorithm, we want to see how does QCue perform in terms of map quality and user perception, and how do users behave in actual tasks. So we conducted a between subject user study to compare QCue with a traditional mind mapping scenario. Here for the 12 users who did traditional mind mapping, We created another interface that looks exactly the same as QCue, but without any cognitive support, a thing without any questions or suggestions provided on their interface. Our intention was to minimize any bias that may be caused by the usage of tools. We chose pollution and underwater camping as the central topics. The topics were selected to provide users with familiarity while also leaving room for encouraging new and creative ideas. So I'm going to show some videos that showcase some interesting behaviors of users using QCue. In this one, you can see that the user first looked at this question, got inspired by this question, and then started to add some ideas at other places in the mind map. For example, here. And the interesting thing is the user did not delete the question. He kept the question there, potentially because he thinks it might be helpful later. So we found that apart from using questions directly, the questions can also help users in providing non-local guidance. Then this one is for the usage of queries. In here, we can see that the user first make a query for the central topic pollution. The query results are shown here. And then he found the one that he feels is suitable to be added to the mind map. And then he started to branch out from there. So from this, we see that queries help in breadth-first exploration also during later stages of mind mapping, where the users usually get exhausted. So we are going to have some qualitative assessment in the following slides. We asked 2 expert raters to rate the mind maps using well-established metrics. Overall, we can see that QCue performed better than traditional mind mapping in terms of the quality of the maps and the ideas generated. Specifically, the score of structure indicate that the question generation algorithm was able to guide the user to generate well-structured mind maps. And the good scores in exploratory and variety indicate that the questions and suggestions did help the users to explore diverse directions. Then we're going to take a look at their idea generation frequency over time. This is the general trend on how the users generated ideas using traditional mind mapping and QCue towards the 2 central topics. We can see that with traditional mind mapping, the users kind of reaching early saturation for both topics, while QCue users maintain relatively good stability of adding ideas throughout the session. Then, when we separate out the added nodes based on the 3 input mechanism, we then further notice that generally, the users appreciated questions in the middle stages of mind mapping. For open-ended tasks such as underwater camping, we further found that increasing amount of question nodes were answered in the early stage of mind mapping. So this all suggests that users were generally more engaged in the process of exploration and reflection using the provided questions and suggestions. This is one example of user-created mind map for underwater camping using QCue. In the post-study surveys and interviews, users reported that questions help them develop new lines of thought. We also found that questions are especially helpful for the topic that is not that straightforward, such as underwater camping. And the users were engaged in the process and excited to use it again for a full-field brainstorming session. For more details, please watch the video on our lab website and read our paper as well. Thank you for your time.